Right, I want us to look at how they set this kind of problems in our examination, both similarity and proportionality theorems, as well as the first one. Triangles with equal altitude have the ratio of their areas equal to the ratio of their bases. A line drawn parallel to one side of a triangle divides the other two sides proportionally. If two triangles are similar, then the ratio of their sides are the same. So these are the three theorems that we're going to use in this particular problem. When you don't see circles around, you don't have to apply the circle geometry. You apply those three theorems. Right, this is what we're given here. Given that BD is 6 centimeters, it is important that you label it correctly. BD is 6 centimeters. From there to here, it is 6 centimeters. And DC, now it's from here now to there, DC. It will be how many centimeters? It is 9 centimeters. This is given in the information that we're given. Another important, AT is to TC. It means AT over TC. AT is to TC is equals to 2 is to 1. You start with AT, then the 2 belongs to AT, and 1 belongs to TC. So AT is to TC is the same as 2 is to 1. So AT is to TC is the same as 2 is to 1. Remember, these are not dimensions. These are not centimeters now. It is the ratio now. So this is not 2 centimeters. This is not 1 centimeter. It is the ratio. This simply means that if this is 10 centimeters, this will be 5 centimeters. It's just giving us the ratio. Therefore, it is important that you indicate your ratio in a different way. So whenever I'm dealing with the ratio, I put a circle around it. Others will prefer to say, because we don't know this, let's call this x, let's call this 2x. You can also call that root and call this one x, and you call this one 2x. It works well in that way too, right? We're also given that AD is parallel to TE. That's my keyword. AD is parallel to TE. Parallel. Parallel. Ah, that's why we bring in this theorem. Right. We are saying now AD is parallel to TE. Now, what is this saying to us? I've got to hide all this. These two are parallel lines. It will mean that this side over that side is the same as this side over this side. From the proportionality theorem. A line drawn parallel to one side of a triangle, it will divide the other two sides proportionally. It means that this over that is the same as this over that. We're getting that from this information that tells us that AD is parallel to TE. All right, let's move on. Then the first question, find the numerical value of CE over ED. We want to find the numerical value of CE over ED. It's about 1 or 2 marks in the exam, this one. CE over ED. CE, this is CE over ED. That's what we're looking for. Look here. This becomes the key there. We're told that these two lines are parallel. Now, if these two lines are parallel, you think of this triangle only. This triangle. Look at this triangle. Look at this triangle. Look at this triangle. That's the triangle that we're concentrating on. In this triangle, it's number side out 3. 1, 2, 3. Eside start parallel to it, because we're given that these two sides are parallel. It's in the theorem yet. It's a line drawn parallel to one side of a triangle. It will divide the other two sides proportionally. What does that mean? It means that this over this is equal to that over that. Let's write that down. We are saying CE over ED, which we have, is the same as CT over TA. It's the same as CT over TA. What is that? What is CT? You can see it, it is 1. What is TA? It is 2. That is the numerical value of CE over ED. It is exactly equals to 1 over 2, because CE over ED is the same as CT over TA, which is 1 over 2. That's how we got that numerical value of the first one. If we look at the second one, show that D is the midpoint of BE. Let's go and look for D in our diagram. This is where D is. Midpoint, partner down. Show that D is the midpoint of BE. BE. Okay. Show that D is the midpoint of this line from here to there. This is from there to here. Trust comes la, iphakathi nendawo, iphakathi nendawo exactly the midpoint. Okusho ukuthi kusuka la kuza la asikhombisi kuyalingana nokusuka la kuza la. That is what the question is saying. Ukuthi asikhombisi ukuthi D uyini uyi-midpoint, meaning that the distance from there to here must be the same as the distance from here to here. What is it that we know now? We now know that this distance from B to D, we know that distance. It is what? It is 6 centimeters. Okusho thina fanele siprove ukuthini ke? Fanele siprove ukuthi distance esuka la iza la naye ubani? Iwu-6 centimeters. Uma sikukhombisile lokho koba uD uphakathi nendawo, when I'm coming from this side or ngiqhamuka from this side, uD would be what we call a midpoint, a point eliphakathi nendawo. Okay, let's try and do that. Remember the ratio. The ratio is so important. It says this over that. In other words, 1 over 2 is the same as this over that. Ama ratio alingana, not ama dimensions. A line drawn parallel to one side of the triangle divides the other two sides proportionally. Proportionality efanayo, proportion efanayo, that's ama ratio efanayo. So in this second one, okay, in this one, we know that this over that is the same as this over this. But ubani, uC T over T A in terms of ratio, so 1 lokunye ku-2. Okusho ukuthi nangala, whatever dimensions in now, loku it's 1 over 2. Uma ngabe ku-5 loku kumele kube u-10. That is what the ratio is saying. Now sifuna bandile sifuna ukuthola ukuthi u-DE ubani. But uma ngabe ebe u-6 kobe u-D is the midpoint. That's what we are doing here. Let's do it. Ithi lento, this over that is the same as this over this. Kusho ukuthi ratio la izothi na i-ratio ngibhala in round. It's 1 la kube u-2 la. So this is 1 over 2. But what are the actual dimensions from here to here? It is 9. Do we see that? So u9 wami fanele ngihlukanise in such that upiece la u1 la, it's 2 here. It's 1 unit la, 2 units to give us 9 centimeters. So how can we divide such that we've got 1 unit and 2 of it here, which will give us 9 centimeters? Okusho ukuthi le distance esuka la iza la izoba ubani yona le ibe ubani. Khumbula le mase ngibhala le ngala fanele iphindwe kabili kunale ngala, but the distance must be 9 centimeters. That simply tells us that EC is 3 centimeters, one of it. If we multiply that by 2, it should be the distance from here to there. It should be 6 centimeters. That's what we wanted. Now we can see ukuthi kusuka la kuza la 6 centimeters, nokusuka la kuza la ubani 6 centimeters. Therefore, D is the midpoint of line BE because uphakathi nendawo. All that I needed to use here are my ratios. Right. Let's move on to the third problem here. The third problem want us to calculate TE. TE. Okay. If this point here is the midpoint, it tells us that let distance esuka la iza la, iwu-half what distance esuka la iza la. If and only if the point is the midpoint. Theorem ya grade 10, the midpoint theorem. Now, let's look at what we're looking for here. If FD, where is FD? FD, I did not put F there. I think it's here. F is here. If FD is 2 centimeters, remember what D is. What is D? It is the midpoint. Now the question says, if FD is 2 centimeters, FD from there to here is 2 centimeters. Okay. Calculate TE. Remember one thing. This line is parallel to this. I'm just looking for the theorem. Nangu FD la. Nangu line parallel to this one. So in other words, a triangle inside, it will be this triangle. It will be this triangle. Do you see that triangle? Do you see that triangle? Do you see that triangle? Remember, to make life easier, let's take it out and put it here. Let's take the triangle and put it here. But what is the thought that you know in that triangle? Okay, I got see chart. See chart in Jalo see beggar. We've got this big triangle, this one. Remember the solution to this problem are this. This is where we get solution. This gives me ideas. So if I take this gibega la, kuzoba u-E la, kube u-T la, phezulu ubani, ubala phezulu u-B. That's what we have. That's what we have. That triangle. But if I take it lep encane ke manje ngizoyifaka la. This one, this smaller one. This small one here. There's D here. There's F there. and this is 2 centimeters. And there's B there. Ah, what do I know about those triangles? They are similar. You point at the similar number triangles because they must be equiangular. This angle is the same as this one. It's the same angle because I've just taken both triangles from this position. Now, this is the first triangle and this is the second triangle. So B is common on the two triangles. So we are fine. So they are similar. So this one is equal to that one. Let's check the other three angles. Let's look at this angle. We are going to line, nalo line. Sithe banjani, ba parallel. Okusho ukuthi le angle na le angle are what? Are corresponding angles. Kusho ukuthi nawanjani ayalingana. Your grade 8, grade 9 becomes important. So angle E is the same as angle bani, angle D. Nangendlela engwafaka ngayo, angle E is the same as angle D. Ah, they're equiangular. Let's check the last one. Let's look at angle T. Yambona angle T uzofana angle F lapha ya. Ngoba these two are corresponding angles. Le ngaphezulu kwa parallel line na le ngaphezulu. Which T uyalingana angle F. So this one will be equal to that one. So these two triangles are similar. You can see that the two triangles are now similar because they are equiangular. Their corresponding angles are equal. Amehlo kamawakho ahlele endaweni efanayo namehlo engane. Lezinto ziyahambisana. Umehlo ofana nondodakazi wakhe. So we say those are similar even though bengalingani. Right. What do we know about similar triangles? We know that if two triangles are similar, then the ratio of their sides are the same. Then we can say AB over DE is the same as AC over DF. We know that from similar triangles. So once we have them in front of us like this, we can then conclude. Left side over left side is equal to left side over left side is equal to left side over left side. But depending on what we want. What is it that we're looking for here? We're looking for the length of TE. Can you see TE there? Can you see TE? This is TE. So you start with what with the unknown. In this case, Singati. Okay, let us check what we have first. Sithathe le diagram sayimisa lapha. Okusho ukuthi siyamazi uBE, distance BE, BE. This distance we know. We know this distance uBE. Ubani uBE? Remember from here to here is 6, and from here to here is 6. So distance BE is how many units? It is 12 units. So we know that this distance is 12 centimeters. Right, it is 12 centimeters. What else do we know? Okay, let's try, because this is the side and the other side. Let's check if we know side BD. We've got to have only one unknown, which is this one. I'm glad we know that one. We're just trying to find the other sides that we'll be using. Now, once we have this, it will be divided by this one. We've got to find that one so that we can have only one unknown. BD or DB. Let's check that. BD. Do we have the side BD? On the bigger picture, do we have BD? How many units is BD? BD is 6 centimeters, and we're given there. BD is 6 centimeters. So you go to BD and you push in your 6 centimeters there. 6 centimeters. Ah, we've got our dimensions. Let's check them. 1 and 2. There's only one unknown. Therefore, we can find the solution. Let's do it together. We know that if two triangles are similar, then the ratio of their sides are the same. Let's do the ratio of the sides. If I'm taking the side that I'm looking for, you always start with the side that you want. In this particular case, it's TE. It's TE over little side over little side is equal to little side over little side. That's what we're writing. Similarity theorem. So it's TE over DF is equals to BE over BD. You write what you know. You leave what you don't know. You only write lento yazi. Ongayazi uye ngoba izokufeyilisa. What is it that we're looking for there? Sifuna bantila lapha, sifuna TE. Okusho ukuthi sifuna ukuba no TE is equal to something. So let us make TE the subject of the formula. If we do that, our TE will cross multiply. Our TE will be equal to, take DF, you multiply it there, so it will cross multiply. So it's going to be DF times BE over BD. That's what we have. Let's put those dimensions. So TE will then be equals to, do we know what is DF? Look at our diagram. Do you know what is DF? DF, yes, we know what is DF. It is 2 centimeters. So DF is 2 times BE. Do we know BE? BE, yes, it is 12 times 12 over, what is BD? BD. BD, we do have BD, it is just 6 centimeters. Also write it here, 6 centimeters. What is our solution? Okay, 6 we are going to 12, we are and 2 times 2, therefore TE will be 4 centimeters. So this is how we find the TE. Alternatively, the easier way of getting TE in this particular problem would be to say, since D is the midpoint, if this is the midpoint, then in distance, you have 1 distance. So if this one is 2 centimeters, TE will be 4 centimeters using the midpoint theorem. You got grade 10 work. All right, that's how you go about finding that. Let's look at 1.4.